Hello and welcome. I'm Bill Wake. We're working on a program to assess the similarity of musical tunes, and we've added this notion of quantizing, which is kind of taking the rhythm and standardizing it so you can compare tunes more easily. And we're up to the point of working through the meter of the tune versus the note length, and there's some rules in ABC notation we need to make this need to make it work so it interprets things correctly. All right, let's see, we'll go back over here. So, whoops, sorry. So this one, if you have an M, well, L is the note length. So when you give a note like A, B, C, what's the default length of it? Well, we've hard-coded it to 1/8 for now, but the rules are really more complicated. If you don't specify it, if you specify it, okay, that's what it is. If you don't specify it, we need to assess the meter if one exists. And if the ratio on the meter is less than 3/4, we make it 1/16. Otherwise, if it's a free or something more than 3/4, we make it 1/8. Default to that. Okay. And I think another thing that occurred to me, let's see. Does free meter have the right rhythm? We gave it this monstrous default. I'm wondering if we can get by with 0 now. And also rhythm, I'll say versus LCM. We had a situation, well, it was while we had a bug or we weren't really fully supporting the free meter for our quantizing, and we ended up getting these very huge multiples. Now, most of them have common factors that could have been taken out because they're all basically ratios. So I think we should maybe do some simplification, but I've got some complexity in mind around that. All right, but we're going to start with this one, the M without L. And we already have a test for it, and it's already failing. I think. Okay, so if we say 23/30 seconds for the meter, that's just less than 3/4. I don't know if that's confusingly less. You know, I think 11/16 would be just as easy to work with. Oh no, but I wanted to specifically use a different ratio than 1/8 or a 16th. So okay, we'll do it this way. All right, so we're saying for free meter, default note length is 1/4. That's just not right. The default note length should be 1/8 for free meter. Oh, well, this is not even free meter. We duplicated a test name. Oh. I don't know what's going on there. Well, the name is wrong. Okay, it's 1/8 for free meter. Yes, that's true. Is 1/16 when meter ratio less than 3/4. Default note length is 1/16 when meter ratio is less than 3/4. Okay. And in this case, we're specifying a meter, but no length. The ratio is 23, 20, 30 seconds. All right, 24/30 seconds will be 3/4, right? So this is just less than 3/4. So it should come under that rule and make our notes all be 1/16. All right, but what they're doing instead is 1/8. Let's run this again, make sure something was odd before. What? It doesn't get a dot, but yet it failed. This one says there's failing tests, but there's no thing. I don't think something's right. Let's try that again. That's better. I'm going to run them all just to get things cleared out. Okay. 1/8 is not equal to 1/16. Good. Okay. Now, there's a bunch of things coming together on this. Let's see. Mostly we want Tune Builder. Do I have it here? Not really. Okay, so Tune Builder has a set unit note length, and you set it. That part seems okay. The problem is, if you haven't set it, we have it initialized, and we initialize it to whatever tune state does. Well, tune state does 1/8. Okay, that's just not right. Okay, and so we need to kind of. I think this is a situation where we need to keep state outside of this initial state, and it's really it's sort of the partial state that we're accumulating. We can't really judge the initial state until we've decided we're ready to make it, and we never had an initial note length. Okay, so I'm going to add another variable. I think it's private. This is initial note length. Okay. Of rhythm question mark. Okay, so I'm not. I'm an optional type, so I'm not assigning it per se. Even this is probably a little odd, but okay. What I want to do is assign this, and let's get this thing. We start out nil. That's fine, but when you set note length, we should assign to it. Set note length, initial note length equals length. And then I'm going to say this should happen down when we do make. Okay, so we're going to say initial state dot in unit note length equals initial note length. Okay, so I'm not trying to make anything happen differently yet. That will come. Okay, and I may need a bang on that. Yeah. Okay, so the way we are today, we're saying let's do this differently. Let's say if initial note length equals nil, unit note state, maybe it's not equal nil. If we did set it, we set the initial note length, and if we did set it, we want to copy it in and use it. Okay, I think that's an accurate reflection of where we are. So all the tests should pass except that one. Good. Okay, so now this one, the rule is if the note length is nil and well, let's go read it again. L note length. Okay, if there's no L defined, set it based on the meter field. Calculate the meter as a decimal and decide whether or not it's a 16th or an 8th. Common, cut, none, default to 1/8. Okay, so this, let's see. So I think in our tune builder, if the note length is nil, we have to do that complicated thing. If the note length is not nil, we're just going to copy it in. Okay. So if they set it, that's fine. If it's nil, we got to do something else. Okay. And now we can look at the meter and make the decision. Okay. So if initial state dot meter equals well, I can make this a 1. Okay, if the initial state dot meter is free, I guess I want to ask the meter, are you, well, we don't have a word in here that describes it, but if it's less than, I mean, I'll call it short. I mean, I guess I could just ask at the preferred note length, right? Okay. Let's do that. Else initial state dot unit note length equals initial state dot meter dot preferred note length. Okay, which doesn't exist. Okay, and so I'm going to go to meter. And it's got a rhythm, but I want to ask it preferred note length of type rhythm, and we need a getter for that. Okay, so right now we just return rhythm 1/8. Okay, and again I'm pushing. I'm expecting all the tests to keep passing except that one, so I'm doing things on that line. Let's make sure that error went away. Yeah, that's weird. How are you running tests if you've got an error? Let's try a straight up build. Okay. All right, so we're pushing the decision in. I saw the, well, we know what's wrong. Okay. We're not getting our 16th. All right. So now meter needs to enforce the rules. So if the meter is, well, I guess if self equals free, return rhythm 1/8. Else if, well, I guess we got to take our meter, our rhythm. Okay, we can. Let's just do this for a moment. And 1.0. We're going to return the no, we're going to return, if it's less than 3/4, we want rhythm 1/16. Okay. Otherwise, return rhythm 1/8. What we plan to do is try an int. What the heck? These are just ints. Do I have to do this one times 1.02? Cannot be applied to it. That operand is just totally weird. I think I like it better on the front. Well, this is clearly in the wrong place too, but let's see if it works. So build binary operand. Oh, what the heck? That's not a rhythm? Okay, R is a rhythm. R dot numerator. We just had rhythm up here. It's numerator denominator. What the heck is stride? Is that not a double? Come on, Xcode. Wake up. Okay. It should pass. Good. All right. And let's get this one. That's 3 meter. Whoops. Mirror. Default length is 1/8, and we should have this working already. 24 30 seconds. It should be 1/8 and 1/8. Okay. This is enforce that if no unit note length is specified, take the ratio of the meter less than 3/4 goes to 1/16, greater than or equal to 3/4 goes to 1/8. Now the little alarm bells go off. This little bit of code already has some feature envy in it. The ratio thing is something we can look at. Okay, here I'm taking the rhythm, I'm doing stuff to it. All this stuff depends on the rhythm, not the nothing to do with the meter itself. So we should be asking the rhythm for its version of that. Okay, and let's give this rhythm, and we'll call this the ratio. And I think I don't have a good sense yet of when I want a function and when I want a variable, but I'm going to give this one a variable, or the feeling of a variable. Public var ratio of type double, and the way you get it is this. We don't need the r's here. All right, since everything in there was talking about rhythm, we'll just do this, and we'll call that we'll say rhythm.ratio and get this variable out of here. And we'll flip it to this form. And then, I don't know, nobody wants to agree with me, I guess. Like the automatic tool should do exactly what I want when I want, but I tend to write this way these days. So just kind of emphasizing that. I did delete an extra brace, didn't I? Okay. Yeah, it'll reformat it for me. I could do worse in that format, but I do like this better. Okay, so preferred note length, if we're a free meter, then we just say 1/8. Otherwise, we look at the ratio, and that is fine. Okay. So we extracted rhythm.ratio. Now, I have some qualm about it being on our domain class, but I don't think it's an unreasonable question. I mean, we ask it because the ABC format wants it, but I think it's reasonable enough. All right, now, rhythm. All right, let's see what else. I mean, this is all pretty clean. Oh, I have a feeling like this does not matter now. I think we can make it the simpler thing of 0, 1. I think there's only one reference to this free rhythm thing. Yeah. Yeah, it's a test. Okay. I'm going to inline this. Take this out. I thought it was a little confusing. Oops. maybe we change our decision someday, but that's kind of where I am now. All right. Let's see this. Handle M. Okay, we've done that. What did we say? Note length versus meter. We answered that one with 0. Okay. Rhythm versus LCM. This one... let's push the question up for a moment. Okay, so my theory is I don't know who cares that it's equatable except tests. So I don't think we use equatable in real use at all. In the production use, I think it's a testing thing. Meter event. Oh no. Okay. Okay. Then I'm good for now. Right now, rhythm compares exactly. Meter compares exactly. A standard rhythm is not a standard rhythm of 4/4 is not the same as a common, which is default 4/4. Even though they have the same rhythm, they're different meters. I don't think anybody really cares, but if they started to, we'd have to make some adjustments. All right. So I'm going to take that out and just leave that as a future thing. Okay. Yeah. Last two things on this rhythm stuff, meter stuff. Let's give this the kind of header, meter and note length. Okay, so the one I'm concerned about, like I said, we saw this when we were testing way early in the meter stuff. Okay, so we had free rhythms defined as like 1,000,000/1, meaning like just take as much space as you want. But then when you use it, you get 1,000,000 times this and 1,000,000 times that, and it's like, ooh. I think what we really want to do is this is one of these things where the music of it is the music part of it is a little different than the mathematical part. Okay, in mathematics, if you have ratios of two integers, you can always take out the common factors, divide them out in the top and bottom, and put your ratio in reduced form. And that tells you that 4/4 is the same as 1/1, so why not just call it 1/1? And for many purposes in music, that is true. I mean, it works out kind of the same. But there are times where you kind of wanted to know that, like, this one's 4/4 and this one's 4/8, and I want to enforce that. Even if we take these common pieces out. So, like, here's numerator times base rhythm. Okay, that's fine. This one, we multiply the numerators and the denominators. And if I multiply a 16th times a 16th, well, I'm going to get, a 256. But the fact is they both could have common factors. Since they're both 16ths, I could have just added them and been done with it. Like what I want to do is figure out, well, I find myself asking for the least common multiple. So if I have the numerator and denominator, well, if I have the two denominators and I find out the least common multiple, then I can multiply each by the number that makes them that and do the same to their operands, and everything comes up, and yet there's still the least common multiple. Now, in reality, in normal music, I don't know how to say it that better, but typical music, all your notes are like quarter notes, eighth notes. They're all powers of 2 on the bottom. And so this becomes very likely to be a multiple of the other one. Or they may share a multiple. You know, if it's 4/4 versus 1/4, they both share that 4. But I would rather keep them in fourths, even though they might boil down to, some smaller ratio. Okay, so if I knew the least common multiple, I mean, this one too, adding them, and this is all kind of fractions. I think I looked, and Swift does not have a ratio type. There's some libraries out there, but Swift ratio is some other thing. Swift data types. Yeah, it's a tough week. You got all that Black Friday spam. Okay, let's look for ratio. Not found. Okay, well, there's the reference manual, if I can find that in there. I don't think that's going to... Right. I mean, it's not a built-in type. It might be a class. Where can we find that? I don't know if we get a language reference. No, I really want the library reference. Standard library. Lots of configurations and durations. Yeah, I'm not seeing it. Okay. One last chance. No. Okay. All right. So what I want to do is I'd like to change multiplication to say get the least common multiple, and you know, do that. Okay. So let's put it here for now. It's really an int extension we should do. So, and I'm going to be very lazy here. Swift least common multiple. I imagine somebody's written this for me. Okay. I'm not seeing a lot of Swift in there. Well, let's just try algorithm. Yeah, thank you. Express them as a product of primes. Yeah, I really didn't want to factor these things. Multiply and divide by the greatest common denominator. Okay. Well, if I had the greatest common denominator. Okay. Yeah, this is basically Euclid's algorithm, very classic algorithm, only a couple thousand years old, maybe 2,500. All right, so you start with the remainder 0, you calculate the remainder, reduce the divisor by that, and then leave the remainder until it gets 0. Okay. Yeah, I'll kind of steal this. That looks... Oh, what's this one? Phase 0, base 0, turn 0. Oh, LCM. Okay, yeah. Let's put, well, let's do this right. Let me see, parser, domain. I guess it's part of rhythm, right? So it's a domain. We'll add a file, and this is a test. Let's make it int plus LCM. Tests. Okay. So we're going to add that. I can do this here instead of waiting till I crash. All right. So the least common denominator. I don't know how we want to define that. Let's paste this in here. Whoops. Wow, that's ugly. Right. I mean, it doesn't mean anything. Okay. LCM of 0, 0. Hey, happy Thanksgiving. Nice to see you again. Let's see. So, well, it's not defined really. So maybe I just shouldn't do this case. Let's do 1x is x. Okay, so we're going to take numbers. We want to say, well, if I'm going to extend it, I can just say 1.LCM of 2 so its least common multiple with 2 is 2. And for that matter, 10 is 10. Okay, now, yeah, and it has no member. Take this out. And let's go ahead and put that LCM class in. Okay, so we'll put it in domain. It's being used there. I don't know if that's quite right. Oh, so if you just got here, what we're doing is Our rhythms, they're just really ratios, but we don't have a ratio class to hold them. And then so when you add and multiply and add them, you multiply denominators and they get these big numbers. And over time, they get to be really big numbers. And there's no reason to. They should all be ratios of each other. So my thought is to simplify them to use least common multiple, which needs greatest common divisor. But by doing that, we can just add them and keep their numbers from getting too big. And we want to keep the base number. So if I do a fourth plus an eighth, I would still like it to be eighths. Okay, because 4 goes into 8. I don't want to reduce it. So if it's 2/4 plus 2/8, I would rather have it be eighths from a musical sense. Okay, in a pure numeric sense, I would rather just get rid of all the common factors, but I'm not going to. All right, so LCM, let's keep that here. Okay, so this is an extension on int, and it's a public func LCM, and it takes other of type int, and it yields an int. And let's just make it live for now. This test should fail. Okay, and both of them get 2. 0 is not 2. Okay, yeah, we just defaulted it to 0. All right. Well, I think right now we can just say other. I don't know, I'm taking small steps. But it's a pretty simplistic thing. Okay. And I'm going to cheat. I'm just going to take somebody else's implementation. This is GCD. Horrible mess as that is. Okay, if you have the greatest common divisor of two numbers, do that. Okay, wait a minute. What's this test doing? Those answers look funny to me now. Why 0? No, you're not right. Oh, it was 0 before. Okay, we returned 0. Oh, sorry. All right. Let's take self times other divided by self.gcd of other. Okay, that's just least common multiple is multiply the two numbers divided by the greatest common denominator. Maybe GCD would be better. Not sure. Okay. All right. This thing gets that. Okay. I'm not going to worry about... Well, maybe I can do it with precondition. I don't really expect it to ever be an issue. Okay. I need them all greater than 1. Okay. Now, this, I don't know, maybe I should just fill out all these tests, bulk them out, and see what goes. Okay. Least common multiple is 2. Another case is 24 and 32. 24 is 3 times 8. 32 is 4 times 8. So the least common multiple think 96 times. Wait, 2 times 8, 3 times 8, 4 times 8. Is it 12? No. 12 times 8. 96 is 4 times that, 3 times that. Yeah. Right. 48 does not work. Okay. Now let's get some funny ones. I don't know how funny we can get. If I take 2 times 3 times 5 and 3 times 3 times 7, that, okay, I got to get at least 1 2, 1 3, 1 5, another 3, and a 7. Okay. I guess that would convince me. Since I'm gonna cheat. Okay. All right. So var remainder equals 0, and then I don't even know if I need that. Okay. Do remainder equals A and B. I guess I'm going to do this. Var A equals self, var B equals B is an int. Okay. Okay, we take the remainder. We assign A equal B. And B equals remainder. And return A. Okay, what does Swift do for a do while? Is it repeat until? Oh, repeat while. Okay. Repeat while B greater than 0. Eventually B becomes 0. Is that right? Okay. I mean, I know I did this years ago, but let's make sure. Okay, so you got some numbers. You're going to take the remainder of A and B. If A's bigger than B, I guess that's okay. Well, let's see how our tests do, then argue our way around it. 1890. Well, that's 2 times 945, which is 3 times 315, which is 3 times 105, which is 5 times 7, right? 23357 is not equal to 630. 9 times 7 is 63, 25. 25337. Okay, 630 is certainly divisible by 6. 105 still is what, 5? What's wrong with my math here? $18.90 is 23357. Let's see, 630 is 2 times 315, 3 times 105, 5 times 7. No, 5 times 7 is 35 times 3. Oh, wait a minute. Sorry. 1890 is 2 times 915, which is 3 times, no, 2 times 945, right? Which is 2 times 3 times 315, 2 times 3 times 3 times 105, 3 times 5 times, well, 100 would be 20, so it's 21. I am so confused. 21 is 3 times 7. So that's the product of them. $630 is 2 times 315 is 3 times 3 is 105 divided by 3 is I don't know. Blanking out here. Well, 9 times 70, so is that times 7? Okay, we got 1890. But 630, does that work? 2 times 3 times 5, yes. But 3 times 3 times 7, yes. 630 should be the answer. All right. Now I gotta think. Okay, so we put in 235 and 337. Okay, so A is 335, 337. Remainder is 0. Well, that doesn't make any sense. Let's just check it as. Remainder is A divided by B, or A mod B. Just put the prime factors. Okay. 2 times 3 times 5 modulo this, well, it's smaller, so it should be itself. So the remainder is 235. A is 337. B is 235. That's kind of a swap, isn't it? We never look at remainder. Okay. All right, so A becomes 337, B becomes 235, and we go back, B is greater than 0, yes. Go back to the top, we take the remainder of this one versus that one. Well, 102, does that seem right? I don't know. Maybe let's just do a trace. I'm just going to worry about this one for now. All right, run that. Okay. Whoa, wait, what? Rem equals 5. 2 times 3 times 5 is 60 versus 63. Oh, I'm not even doing arithmetic right there. Okay. Yeah. 60. B is 5. Why is it 5? I'm going to print A and B too. I feel like borrowing the code, I'm even worse than I was. Okay. Initially, A is 5. Wait. Oh. Okay. Yep. All right. Parenthesization error. Okay, good. And this. Oh, yeah, I can do that. Okay, take this out. Now, I don't know if I can do this without that temp. Can I? Yeah, I think that's better. I don't think you could ask for much simpler there. Okay, AB equals B, comma, A mod B. Okay. Okay. Right. So I think we're just about there to make the changes in rhythm. Before we do, I think we'll just take a quick break, 3 or 4 minutes, and we'll come back and apply our LCMs and GCDs if we need it to adding and multiplying fractions. It's like reliving grade school again. All right, see you in about 3 minutes. All right, hello, welcome back. Okay, we're gonna go apply some grade school arithmetic. um, Numerator times base and denominator times base. Well, let's do times first. Okay. So let's see. If you want to multiply, talk about refactoring. We are doing it for real here. Okay, you got A times B. Well, let's say A over B times C over D equals A times C over B times D. I guess we could parenthesize. Okay. And, sorry, it does not equal that. Is that it? E times C over B times D. Yes. Okay. And, but we want to take out the common factors of A times C and B times D, right? So, let's see. So I think I want to say, what am I going to convert this? What bottom should it be? Well, it doesn't have to be B times D. If B and D have common factors, right? I could convert it to the least common multiple of CD. Let's see. I may have to work this out. Let's say X equals LCM of BD. Okay. Now, if I divide B times D, I don't know if I want the greatest common denominator. Well, certainly I could do A well, I'm going to call it A. I don't know what I'm going to call it. A slash B. If I then took A what about B slash X? Okay, so B slash X is, I don't know, I'm blanking out here. I haven't even stuffed myself with turkey yet. Okay, if I take B over X, that's maybe I want X over B. If I take the least common multiple divided by myself, that should give me the factors that I need to multiply by. So I think if I take X over B times A, divided by well, it's really divided by, it's really x over b times b. Okay, does that make sense? I'm multiplying the top and bottom by x over b, okay? And that should work out mathematically. All right, but that's equal to x over b times a. Not much you can do there. But the bottom then becomes x over b times b is just x, assuming nobody's a 0, which we're going to assume. Okay, so that puts the first number in terms of x, right? And then the second number, I'm going to do the same thing. I'm going to take, for c over d, if I take x divided by d times c all over x divided by d times d, that equals x over d times c divided by x. Okay, and then the product is really the sum of those two, x over d times c plus, well, let's do the other one first, x over b times a plus x over d over c all over x. Okay, so if I have two numbers, they have the same denominator. To multiply them, I just take the sum of their things. So 3/4 times 3/4 is, no, it should be times the square, shouldn't it? Wow, you get rusty with this stuff. Okay, that's over x times x, but why do I need the x in there? And the worst is I'm trying not to reduce things if I can, but maybe that's just a fake worry. Maybe it shouldn't even be a worry with times. And I don't know, I'm saying that wrong too. It's still times. Well, what does that give me? LCM I don't know. Maybe I'm fighting too hard. Okay, that is certainly true. The first line is true, 29. Now, if I knew is b times d bigger than x? I guess it is, right? Because worst case, it's equal, but usually it's less. Okay, well, I'm confused. If the I'm trying to think of a case where the product well, I'm not sure this is giving me anything, I guess. So if the product, well, what it's giving me is x squared is always less than or equal to b times d. So it is simpler. Is it worth the effort? That I can't say. I guess it is. So if we had sixteenths times sixteenths, right? Let's say 4 sixteenths times 8 sixteenths even. Okay. The product directly would be, I'll write it down because I'm apparently not in a mood to do it in my head. Okay. If I do those, that is 32 256. Okay. If I do the other way first, the least common multiple of 16 and 16 is 16. X equals 16. And then I want to do x over b. 16 over 16 is 1 times the 4, which is 4 divided by x over b is 1 times b is 16. All right, that already seems funny to me. Times, well, let's do a different problem. Okay, 4/8 times 8/16. All right, 4/8 is really 8/16, so this is 16/16 is 1. All right, if we take the least common multiple, that's 16, and then my lovely algebra there says x 16 divided by b is 8, which is 2, times 4 divided by x over b is 2 times, well, divided by x, 16. Okay, x over b, well, let's do that. X over b times a is 2 times 4 times x over d, well, x is 16, d is 16, so it's 1, times c is 8 over x squared is 256. It's still not right, because that's 64 over 256, which is equal to 1/4. Okay, let's sorry. Let's go back to okay, simplification, right? Multiply the top numbers, the bottom numbers, cancel out the common factors. So the greatest common divisor of those two, right, is 8. Let's work from there. GCD equals 8. Say it this way. Greatest common factor. Oh, yeah. I don't want a video. Yeah, I don't want to do it that way. Method 2, greatest common factor. Okay, divide the top and bottom by 2. The only denominator divides our numerator denominator. Do I have to do that at the end? So I think what that's saying, golly, where's a 9th grade algebra student when you need one? Okay. I think it's saying A times C divided by B times D equals A times C divided by GCF. Oops. Divided by B times D times D divided by GCF. So if you knew the greatest common factor of both of these, you would multiply and simplify. And it's the greatest common factor of numerator and denominator. Have I chosen the wrong thing? That's what we're saying, right? Divide them both by the greatest common factor. Okay, let's go back here. The greatest common divisor of 1 and x is 1. Sorry, greatest common factor. Well, the divisor's okay. Let's make this one public too. Okay, this test should pass. Okay, and then same corresponding one. Okay, the greatest common divisor of these two should be the same as itself. The greatest common divisor of these two, this was 3 times 8 and 4 times 8, so it should be 8. And the greatest divisor here is 3. Two, 3, 5, 3, 3, 7. 3 is the only common factor. Okay, let's make sure this one's right. Okay, let's try this with this then. We'll take out LCM if it's... where's rhythm? Over here. Okay. So in the end, I need AC I need BD. I need the greatest common factor of those two. Okay, so other numerator. The bottom is self.denominator times other.denominator. Okay, GCF equals top.gc top.gcd of bottom. Okay. And then we want to take this. Well, the slash goes away in effect. Okay. Return rhythm top divided by GCD and bottom divided by GCD. Keep that away for a minute. Okay, well, for all my fussing, that looks pretty simple. All right, do we believe it? Well, we're getting the common factors. They're in both the numerator, the numerator, the top and the bottom. Okay, so all the factors of both, give me the common factors and use that, reduce, since they're common factors in both, reduce. Okay, this should pass all our existing tests. Well, didn't you supposedly pass a minute ago? Oh, those should be GCDs. Okay, so make rhythm use GCD when multiplying. Okay, and I think it's definitely okay mathematically. I guess I'll live with it musically. I don't think I need LCM anymore. All right, and let's change the name of this file then. Into GCD. And, well, let's make sure that works, then we'll do the rename. Okay, so that is rename. Okay, we'll take this out. All right. Well, that's pretty reasonable. All right, now this one. I almost want to do this the same way. I mean, this is multiplying these two. Let's use our times. Rhythm of numerator denominator times base rhythm. And then the self.denominator is the product.numerator. And this is the product dot denominator. Okay, so rhythms multiplying initializer uses times. Okay, which I think feels better. All right, and now plus. All right, let's go back to our algebra board. A over B plus C over D. All right, so that is A times D. You multiply the A times the bottom of the other, plus B times C all over B times D. Okay, and we do the same GCD thing. All right, so it's a little different. Okay, so it's self-dot numerator times other denominator plus self-dot denominator times other numerator. Self-dot numerator times other denominator plus other numerator times self-denominator. I switched the order, but I think that's okay. All right. The bottom is the product. Okay, that's good. And then the rhythm is, the GCD. All right, so we take the top divided by the GCD and the bottom divided by GCD. I'll space this out a little just to make it consistent. Oops. Okay, and so our plus makes use of that. All right, good. Make rhythm dot plus use GCFD. Okay, that covers this. I think we can say it better. Make rhythm use GCF to multiply or add values. Cool. Okay, is there an emerging cumulative beat? This quantizer thing. Well, let's look at it again. Let's just close these. Open quantizer. Okay, so the deal is we get this, we get a measure in, and it's got, it can give us the symbols in the measure. We're just getting them one at a time here, but that's okay. But this cluster of things, it's saying what symbol are we going to get, and how much have we accumulated in terms of rhythm. So let's say we have a quarter note, eighth note. Okay, so at first we will have accumulated a quarter, then it'll be a half, then it'll be 5/8, then it'll be 6/8 or 3/4. I don't know, this last symbol thing, we need that name at some point. Yeah, we need to know the last one that we accumulated. Okay, so I'm gonna do the blind thing. I think this will be a little bit of an experiment, but if it works, we'll keep it. What I'm seeing here is these three fields are coordinated. They always change together, and then when we get to the end, we look at them. Okay, and we need to ask. Well, this question has to know target and measure, but it knows measure because it has to know that to build it. Okay, and this one asks for target and symbol. Okay, so I guess I'm going to create a little struct. Struct, and I think I called it CumulativeBeat. Yeah, that's my best guess at a name for now. Beat. Okay. And it has these three things. And then this is kind of like saying next beat. Okay, so let's give it these three fields. It's counter, last symbol, and beat so far. Is a rhythm. Okay. So I think sorry, where am I here? Okay. Then there's an operation that says increment. Next, maybe. Okay, so there's got to be an initializer. Let's do that. Init, and we always initialize it to 0, counter to 0. Measure, we need to know the measure, and that comes from that. So I guess we need the measure to do the initialization. Okay, and we'll say counter equals 0. I'm just taking this code really. Counter equals 0, last symbol equals that, and beat so far equals that. Okay, so that should be initializing it. Then to get the next one, we have to look at measure again. I don't know. Does measure, can we get the events from the measure? The symbols. Okay, that's kind of an optimization. Let's deal with it later. Okay, so we get the measure. I guess we're going to have to hold the measure as well. Okay, and that takes care of that. And then we want to say next. Well, public function, maybe it's move to next, increment, progress. All right. Well, how do you progress? You do this stuff. Okay, and then self is immutable. Yeah, structs do that. Okay, we'll make it a class. Okay, so I think we have those pieces. Then the question is, what is this? This is can progress versus a target. So I'm just kind of manually pulling out all the functions that I see here. Can progress with target, which I think is a rhythm, returns a Boolean. Beat so far less than or equal to target, counter plus 1 less than measure, symbols count. Okay. And what else we got? Beat so far greater than target. Well, that's can progress. This is can report. Maybe. Or has note, has symbol for a target of rhythm. And that's so why is that opposite? Okay, I think it'll be easier to see inside once we get going. All right. And then let's make that gettable. I don't know if I can say this in the other order. Okay, we'll take that out. Okay, we'll make this public for a minute. I just want to get this thing moving. All right, everything should be passing. We haven't referenced this at all. Okay, so now I'm going to make use of this thing. All right, so here I'm going to say var accumulator equals beats cumulative beat with measure. Okay, that takes care of that one. Then this is accumulator can progress versus target. And I will comment out that for a moment. Okay. And then this one, these three together, they are accumulator.progress. Okay. Now beat so far greater than target, that is accumulator dot has symbol of target. Okay. So I hope I've systematically replaced everything. I think I have. And this should all just work. All right. Add cumulative beat class. Use it in quantizer. All right. Now we'll simplify quantizer. Delete these comments. Okay. That should be fine. Okay, and whoops, these three. Okay, I guess I wanted to boy, this okay. What I'm seeing is this paragraph has nothing to do with, well, it only has to do with accumulator. I could ask accumulator to do this stuff. Okay. What can we do? Well, let's give it a method. Let's make a method of it. Okay. Progress. I don't know what to call it, but let's just say move forward. And once we have all the pieces, we can do it. All right. So we need another target. Okay. So that just runs through this until we reach the target. This is self. Well, I don't need the word self there, do I? Okay, and then I call it move forward. So that was accumulator.move forward to target. Well, I think we could make a phrase for that. Should all pass. Okay, so let's work on the names of things here then. Okay, result is symbols. accumulator has a symbol, then get its last symbol. Okay, I think that's better. This is really like move to or move past. What's he actually doing? While beat so far less than equal target, then we're going to keep moving. I think I can call it move to. This, we don't need to be public anymore. Same for this. Beat so far less than equal target. Why is that has symbol? Maybe this is past target is a better way to say this. Okay, so not greater than is the same as less than or equal, right? So we can flip this. If we're not past the target, where's begin? If we're not past the target, and we got less than that. Okay, that looks good to me. Okay, let's take our progress there. Rename and simplify. Well, we extract another method to cumulative beats. Rename and simplify within that class. Cumulative was never mutated. Well, we're dealing with the same one, okay. Yes, we didn't change the variable, we do change the accumulator. All right. Now, the last thing is, I think we don't want to give it measures. Really, measure.symbols is what we care about. So I'm going to change that type. And this is going to take symbols of array of symbol. Let's say symbols array of symbol. And everybody who was using measure should be using symbols now. So pass in symbols rather than measure to cumulative beat. Okay, so cumulative beat, I don't know what it means, right? So I don't have a better name, but we're taking the symbols. Let's make this has passed. Has passed, maybe this way. Got my homonyms confused. All right. If you haven't passed target and you've got more symbols, okay, progress. Maybe this is step. And this is then can step. Okay. So I don't know that I know exactly what it means, but it it is compressing these things together that we care about, and I think it's a step forward. I may come up with a meaning for it at some point. Move past. Move to. I think it's move past, right? Because we haven't passed it. How about move just past? Okay. So this is one of those weird little emergent classes, and we're putting a name on it, and maybe it means something. This is different. Okay, I was hoping I could reuse it a little bit. All right, we identify the pulses. We have a return value. I guess I'll move this up. We identify the pulses. We start an accumulator. Then we run through the pulses and move the accumulator just past target. I don't know, a better name for that would be good. Current beat. Target, we move just past it. If it has passed it, now is that right? This is almost like if possible, isn't it? Okay, I'm gonna let it go. I don't have a great. This is really just like attempt to move just past. Let's say try to move past. Attempt. I'm trying to make this read like a story. Okay, run through each pulse. If you try to move past it, if you have, then append the next symbol. And I think if you come in here again with a further target, you couldn't move past the last one, so right away you're going to stop. All right, so I don't think this is really... We changed the way we did this. Okay, so we used to ask the measure, what is your time signature say? But the reality is the measure may have different notes than it expected. Okay, or you may have a free measure which just has notes and you don't know how many there are. So we switched it to say, how many beats do you really have? Okay, and with that, we accumulate all these pulses until we've run out of beats in the measure. So I kind of feel like this can't happen. And to prove that, I'm going to do this, but I don't know. You can't tell it just looking at this code. You got to know the other code. Okay, so somebody got there. Okay, so maybe my theory's wrong. Okay, my theory's wrong. So delete that breakpoint. Okay, so you do... Oh. I was looking for the else clause. All right, let's do it that way. Do we get any couldn't passes? And break here. Yeah. Okay. So I don't know. Like maybe there's more we can push in. Maybe this pulses stuff should come. Like if you told me the total beats of the measure, I can almost get the pulses. All right. I think we'll save that for another day. Let's see, what did we actually do here? Renames and more renames. Okay. Yeah, there's some interaction between identify pulses and this thing. Like, we somehow guarantee that you will always be able to append the symbol. But we can only make that guarantee because we know that we're never going to ask for total beats. More than total beats. Okay. I don't know. Well, I won't even keep it down there, but let's move forward. Okay. Create, whoops, and use beat to simplify quantizer. Okay. I mean, it's kind of a thing right now. Maybe that's good enough. All right. Oh, I put this on the wrong place. All right. Well, in terms of our to-do, we finished what I set out to with that meter and time signature stuff. There's still stuff on the key signature we don't deal with, but I don't think it's what I care about at this point. The other thing is I have another analysis I want to do is analyze metadata. count each occurrence show counts and values. I don't know exactly, but I'm thinking of, like, if I said, what are the time signatures? And it went through and said, oh, 3/4, 1/4, 1/4, 1/4, 3/4, 2/4, 3/4. And then it came back and said there were 4 3/4 and 1/4 and 1 2/4 or something like that. I would get some distribution of this thing, and that would be interesting. And I could do it the other way too. I could sort by their ratio and maybe see that most people like them in the middle, or maybe they like them on the ends. I don't know, but something there. Okay, but I think we want to do some user interface. So let's go forward here a little bit. We got a little time. We won't get far. I'm thinking of the current interface is just sort of a big block of text where you can paste stuff, and then a report field and some possible errors. Just a big, it's a terminal display shoved into a UI. All right, but what I'm thinking is something more like I'm thinking of like a sandwich almost, with these layers in it. But you would put some inputs and you put some outputs, and then somewhere in the middle you might be doing some transformations or analysis. And my idea then is that each option we give you, you could add another transformation. I don't know. We've got quantizing so far, but I could easily imagine pushing everything into the same octave or pushing it into the same key, and letting that guide the kind of transformations. Excuse me, the analysis, we got the Parsons code already. We have this notion of a modal melody, like what's the most common note at this position. And then I just added that attribute metadata analysis. I want those all in there. And then the idea is you would drag and drop them into this vertical column and, set some parameters on them and go from there. I don't know what's involved at all. So it's, it may be more than we can do easily, but I think I'm okay with trying it. All right. So I need to make some sort of list. Well, of a list of visual objects on the left and a stack of objects on the right. I think, do I care more about the left or the right? Well, the right is where things happen. So I guess if I said, well, we only have one structure today and it looks like our target, I would feel pretty good about that. So let's see what we can do. All right, and let me just save this because I haven't done that lately. Okay, so the user interface, let's get back over here. Parsons code, grid, where's our content view? Okay, well, that's interesting. I don't really think of that as being the report. Let's look at the preview. Okay, it is the whole thing. All right, let's see. If I do 0, I guess I'm going to try. So something's weird to me here. This thing. Oh, he locks his frame height. Okay. Well, this object is sort of it's sort of an input object. it really is like a text field input, but I think we can say, well, that's like our overall title. So let's create an object that contains a text editor instead of is a text editor. All right. And I haven't done this in a while, but I should be able to create other structs. Okay, so let's make one. This is a text input view, which is a view. And if it's a view, it has to have one of these. And in our case, we want it to be a text editor. I don't know why we care about the height. It doesn't seem like our business, but okay. Input. We have to pass that in and I know there's a way to do it. I know I have to put it in the constructor. But I think I don't say state here. Let me check my lovely desk here. I had a great little picture that says, when do you use state and when do you use whatever the other stuff is? Stuff I haven't touched in months, of course, but not what I'm looking for. Okay. Boy, I should have that tattooed somewhere. I'm going to put it in bookmarks. Software, Swift, iOS, mobile. A lot of this stuff looks like it should be filed somewhere else to me. Wow. Okay, I'm going to have to do the old searching method. Swift state versus state object. Yeah, that's a good start. Right. If state object, observed object, environment object. And this is, I don't think this is everything. Okay. So state, we've been using that. It's basically a local variable that contains content. Okay. Use state when values are simple. All right. Then we have state object. Instantiates an observable. I don't think we're doing that. Okay. State to state object. Well, let's try a different question. Swift pass state to view. Binding, that's the one I'm looking for. Passing data using binding. Okay. I think I just used the word binding and I'm okay. I have to pass it in the constructor. Pass a binding, okay. Binding. Yep, I'm pretty sure that's what I'm after. Okay, so I need a binding. And the rest of it's kind of the same. Okay, I think that may be all I have to do. I don't know if this example showed anything else. Binding. Oh, we got to pass it to the constructor. Property refers state on the variable is on. Okay, state. Where's control? Where did he pass that? Control view. There. Light is on. Okay, because we're not calling it, there's no issue yet, but let's call it. Okay, so if I do text and input view with input being $input, right? Okay, so accessible due to private. Okay. All right, whoops. Well, let's do a preview. It looks the same. Let's give it a run. Where's our no scale on text? Okay, we got this coming. Most importantly, this looks the same, and we're still able to edit it and so on. Okay, so let's take that progress. Pull. Okay, now now quantizer and report, they're they're really tied together. I don't know. Maybe this thing has to build a bit of a structure. That sort of makes sense, right? If I'm going to make a stack of these things, I'm going to be modifying it. I need an object that represents them. And then I got to map that into these objects. So this is almost like a quantized parameter. But let's make this a separate little view too. I'm going to call this user interface, rename this package. Okay. And then text input view. Let's get quantization parameter view. That's this. What's that? Oh, that's the button. I think he just stopped drawing. Oh, need to rebuild. Content view not found in targets. Well, where's let's clean instead. Okay, it found it here. Let's just go back. Yep, just a compiler bug or IDE bug. All right, so this stack through here is the quantization view. Okay, he needs should quantize. Well, he needs these two. Now, maybe he should own that state himself. I don't know. Numerator, denominator. We don't want them private. Okay. Okay, that all looks right. So this is quantizer setting view. And we need should quantize is dollar should quantize. Numerator is dollar numerator. Okay. We get two of them. Let's take this one out. I would have to say this is overdue. Let's get our no scaling back. Okay, much better. Now the report seems like it's the same. Well, okay. Let's see how this is looking. We got the title, we got the input view, the quantization view. Then I think all this is really report. Down to, well, where's the bottom of that? Scroll view parsons code. No, I think that's part of it too. I guess the end of the scroll view. The errors, maybe those aren't part of that. Okay, let's take the end of the scroll view to the top of the button. And we will make parsons code view, var body, some view. Put that stuff in, see what it's missing. Like everything. Errors, output, quantizer, numerator, denominator. Okay, these become bindings. They gotta lose their initializers. Okay, and oh, should I delete all the types? Okay, yeah, I think that should get them all. Quantizer. I'll put that out here for now. And we'll put the whole thing in a V stack. All right, I guess finally we need input as well. Okay, so I think all right. This should still run. We're not referencing Parsons code view yet, so. All right. X1, T test, KG, ABC. Okay, good. 3 notes anyway. All right. Let's check this in. So add Parsons code view, but don't call it yet. All right. So what we're doing here, we've got each of the major pieces of our user interface is now coming from independent view objects. And eventually we're going to have a model behind them that says this pipeline is these things in this order, and we'll look up and get the view that corresponds and develop that. All right. This is it for this week. Let's see. Tomorrow's the 25th. So 28th Monday is our next time at the usual time, which is 1 to 3:30 p.m. Eastern Standard Time or 6 to 8:30 p.m. UTC. Thanks for joining today, and I hope I'll catch you in the future. Bye-bye.